All right, let's jump right in. We're going on a little journey that I'm sure every single developer has been on. You've got this app, it's running perfectly on your laptop, and now you got to get it out into the wild, into the cloud. And that journey, well, it can feel like you're a detective on a case.
Oh yeah, the classic phrase, right? It works on my machine. And look, part of you feels this huge sense of relief when you say it. But you just know that's just the starting gun for a whole new set of problems.
And that's really the heart of the matter, isn't it? It's not good enough that it just runs for you. How do you ship this thing so it's reliable, so it's scalable, and maybe most importantly, so it's secure? That's the real challenge, and that's exactly what we're going to break down.
Okay, so first things first. We've got our code, our front end, our back end, and the plan is to wrap it all up nicely in a Docker container. Sounds easy enough, right? Famous last words, maybe?
You know the drill. You write a Dockerfile, that's your recipe. Then you build a Docker image from that recipe. And finally, you run the container. 1, 2, 3. Super simple on the surface.
And boom! It works. We've got a running container. It totally feels like victory, right? We've packaged it all up, it's ready, but hold on a second. Is that really the end of the story?
And here's where our detective story gets its first real twist. See, just because it's running doesn't mean it's safe. What you can't see, what's hiding under the hood, could be some pretty nasty security holes.
So, time to switch hats. We're no longer just developers, we're security detectives. We're going to grab our magnifying glass and go through our own Dockerfile, line by line, to hunt down these hidden threats.
And our investigation turns up 4 major red flags. First up, and this is a big one, we're running as the root user. That's like giving a potential intruder the keys to the kingdom. Second, there's no health check, so Kubernetes has no idea if our app is actually healthy or if it's just, a zombie. Third, we're using latest tags. Super risky, you never know what you're going to get. And last but not least, we forgot a dockerignore file. So we could be leaking sensitive files and making our image way bigger than it needs to be.
So, let's talk about that root user thing for a second. Why is it such a big deal? It's all about something called the blast radius. Think of it this way. If a bad guy breaks into your container, and that container is running as root, they don't just own the container. They can potentially break out and attack the whole server it's running on. A tiny little crack becomes a massive explosion. Our job is to contain that blast.
And the fix is actually pretty simple, which is great. On the left, that's the before, the default dangerous way. But on the right, you can see the after. We just add a couple of lines to our Dockerfile. We create a special user just for our app, a user with way fewer permissions. It's a small change in code, but it's a huge change for security. It shrinks that blast radius right down.
All right, so with the big one handled, we can knock out the other issues. We add a help check so Kubernetes can actually ask our app, hey, you still good? We lock down our dependency versions, no more latest surprises for us. And of course, we create that dockerignore file to keep secrets out and keep our image lean.
Okay, awesome. Our container is now locked down, it's hardened, it's secure, it's ready for prime time. Case number 1 is officially closed, but our story isn't over. Now comes the next chapter, deploying this thing into a Kubernetes cluster. So, we do the deployment, we push our front end, we push our back end, we check Kubernetes, and everything looks green. The pods are up, they're running, success. But then we actually try to use the app, and nothing. It's a ghost town. The front end and the back end are completely ignoring each other. A whole new mystery.
I mean, this is the classic the lights are on but nobody's home problem. Kubernetes is telling us, yep, everything's running, everything's healthy, but in reality, there's a total wall of silence between our services. What is going on here?
All right, time for another costume change. We're hanging up the security auditor hat and putting on our network detective trench coat. We've got to follow the wires, trace the packets, and figure out where this connection's getting lost.
And every good detective starts with a solid plan. Here's ours. First, kubectl get pods. Let's double check that everything is really running and see what their internal addresses are. Second, kubectl logs. Let's see if the apps themselves are screaming about any errors. And third, the good old browser developer tools. Let's look at the network tab and see what the client is actually trying to do. So we've checked the logs, we've checked the pod status, and we're still stumped. This whole case, this whole mystery, it all boils down to one single critical question. Where is the request actually coming from? And right there, that's it. That's the aha moment. The case just cracked wide open. And you know what? The culprit isn't a bug in our code. It's not a weird Kubernetes setting. It's a really common, fundamental misunderstanding of how the web works.
Check this out. This is the whole enchilada right here. We thought the request was being made from one pod to another, all nice and cozy inside the cluster network. But that's not what happens. The request is coming from your browser, the one running on your machine, miles away from the cluster. And your browser has absolutely no idea what a pod IP address is. It can only talk to public websites. That's the entire mystery, solved.
This is so important, so let me say it again. The front-end pod's job is just to serve the code. It sends the files over to your browser. But the code itself, the JavaScript that makes the API call, it runs inside your browser. And your browser is the client. It's on the outside looking in, and it can't see those private internal pod addresses. And just like that, case closed. Now sure, the technical fix here is something like an ingress controller or a service of type load balancer. But honestly, the specific fix isn't the point. The real takeaway, the real solution, is about developing this observability mindset. It's about learning how to think like a detective, how to debug methodically, and how to really understand the moving parts of your system. So let's recap the key clues from our investigation. Number 1, always know the difference between the client, your browser, and the server, the cluster. Number 2, pod IPs are for internal use only. They're like the private phone extensions inside an office building. Number 3, have a process for debugging. Check status, check logs, check the network, be systematic. And finally, the big one. Observability is not about knowing that something works, it's about understanding why it works. And I think this quote just nails it, you know? The goal isn't just to cobble something together until the red light turns green. The goal is to truly understand the why. Why it works when it works, and more importantly, why it breaks when it breaks. That's the good stuff. That's where you really grow as an engineer.
So I'll leave you with this question to chew on. Is your job just to write the code? Or is it to own that code through its entire life? To make sure that the thing that works on your machine actually works for everyone, everywhere, every time? It's a bigger question, but it's one we all have to answer now. Something to think about.